So today we will study about the compound microscope, right? Compound microscope, which is used for higher magnification, right? Basically, compound microscope is an instrument which is used to magnify the objects, used to magnify the objects, basically which objects, small objects, like which we can't see from our naked eye. We can't see from naked eye, or we can see them but not clearly. We can see them blur in a blur way, so we can use this compound microscope, right? Basically it it uses two lenses, which are basically two convex lenses, in order to give us the magnified image, right? Basically you can say that it gives us more magnification than stereo microscope. Gives more magnification than stereo microscope. Now you'll be wondering that what is now stereo microscope. Basically the microscope which is used to see objects that we can see from our naked eye, to see objects that are visible through naked eye, like the objects which we can see from our naked eye, we can see them from stereo microscope. So this basically compound microscope has more magnification power than this stereo microscope, right? I hope this is clear to you. Now if we talk about, like as I said, we use two lenses over here. So first is convex lens. Basically we have two lenses. First lens is known as object lens, and second is eyepiece lens. So let's talk about first convex lens, which is eyepiece lens, right? Basically it has greater focal length. Its focal length is very big, and like it is few centimeters is the focal length of this convex this eyepiece lens, right? If you talk about another lens, which is other convex lens, basically that is known as object lens. And the convex lens, basically its focal length is very small. The focal length is very small. Basically it is less than 1 centimeter, right? It is less than 1 centimeter, that focal length, right? So I hope this introduction is clear to you. Now let's look into the diagram of this compound microscope, right? So basically, as I said, we have two lenses. Consider that this is our principal axis, and this is the small one lens, right? And this is that big one lens. This lens is basically known as object lens, LO, right? And this is basically a lens which is used for eyepiece. As I said, this is the optical center. This is F. This is 2F, and here it is F. As I said, that the focal length of the eyepiece one is greater than the object one. So the image is basically between 2F and F. This is the image, so it will go parallel, and then like this is the focus one, so it will meet over here, right? If now we will cross this by optical center. So if you can see over here we got the image. Basically this image is looking very short, but it is not. This image is known as eye, and this eye is basically it is magnified, right? And this eye is real and inverted. I know this diagram is not correct, like now you can see this over here. Just cut this or remove. Let us make another diagram. This is the small one lens, this is the bigger lens, right? And this is our principal axis. This is f, this is 2f. This object is placed over here, so consider this is a focus. It will meet over here, then we'll pause this. So now as you can see over here, now this is great, like magnified image. So this eye is actually magnified, real and inverted. Right now, if it is this optical center, it is focus. Now it will go parallel and it will meet like this, and this will go to the optical center. They are like this. So these line will meet at infinity, but as you can see, the distance between the eyepiece and the lens is very small. We don't have any kind of infinity over here, so we will try to converge them. So at a point, so as you can see over here, we'll converge them as another, and it will form, the image will be formed over here. That image will be known as I2. So basically I, and this point is known as apparent to be converging, right? And this I2 is basically very magnified. The image is very large, and it is virtual and is erect, right? Now as you can see over here, this is apparent to be converging. This is f2. This length from here to here is known as focal length of lens 2, and from here to here is known as focal length of lens 1. This is I1, this is I2, and the distance between two lenses, is known as L. L is what? Distance between two lenses is known as L, right? Now the formula for the magnification of this compound microscope is L upon F plus 1 plus D upon F2. So basically this is the formula for the, sorry, here plus won't come. So L upon F, 1 plus D upon F2. This is the formula for the magnification of the compound microscope. Now you will wonder what is D. D is basically the minimum distance. But the minimum distance, it is basically 25 centimeter. It is 25 centimeter. So you can write this formula as this: M is equal to L upon F. F is basically distance between two lenses. F is the focal length of lens number 1. 1 plus 25 centimeter upon f2, like focal length of lens 2. So basically this is the formula for the magnification of the compound microscope. So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section, and I'll be very glad to answer you guys.